Hi everyone, it's me Angelo, and for today we have special guests Mark Nelson Aguirre, Ken Adriel Junicio, and Frances Nicole Alejandro. For today's lesson, we're going to teach you how to name compounds. But before anything else, let us first get to know what are compounds. Compounds are chemical substance that is composed of many identical molecules and has atoms for more than one element. They're held together by means of chemical bonding. So now, let's begin naming compounds. For the first one, we have Mark Nelson Aguirre to teach us on how to name the type 1 binary compounds.
So now we are going to draw the Lewis structure of Na2S, or also known as sodium sulfide NaS2. As you can see, we need to find the Na, which means the sodium, in a group 1. So let's see, the group 1, here is it. Then we write Na, which is have 1 electron. Then for the sulfur, which is there in a group 16 that has a 6 electron. So we're going to write now 1, 2, 3, 4, 5, 6. To complete the electrons of sulfur, we need to transfer the one electron of sodium to transfer to sulfur. So as you can see, there's have a missing electron, so we need to add another sodium. Need to add another sodium that has a 1 electron to complete the table, or the sulfur. So now let's draw the sulfur that has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, that has borrowed 2 electrons of sodium. That's why we put here the -2 or -2. So after that, we need to write the sodium. So we have this, it's a sodium. We don't need to put dot or electrons. We just need to put +1 that borrowed by sulfur. We need to write it here again because sulfur borrowed 2 electrons for sodium. That's why 2 sodium and 1 sulfur is equal to Na2S, also known as sodium sulfide. So for the final formula, we need to shortcut the diagram, which has 2 times of sodium then we have sulfur that has 8 electrons -2. Here's the final formula for NaC2.
And now, let's have the type 2 binary compounds.
Good day, everyone. I am Ken Adriel Junicio from 12 Harmony, and I'm here to teach you how to solve type 2 binary compound. Here are the steps that you need to follow. First is, the cation of a transition metal is always named first, like any cation, and the anion second. A monatomic meaning 1 atom, cation take its time from the name of the element. For example, Mn2 is called manganese 2. In the name of compound containing this anion, the number in parentheses is the charge of the cation. All transition metal called cation must show the oxidation number. Charge in parentheses following the English spelling of the element such as iron 3, copper 1, or vanadium 5. Whenever a compound containing these ions which is multiple change is named. For example, manganese has 2 plus charge, ion will be written as manganese 2. For our anion, it is always placed second before the cation. Sulfide is also refers to the chemical compound belonging to broad families of inorganic and organic compounds. That's all. Thank you. I hope you get some information and you have learned something.
And for now, let's have the type 3 binary compounds. Naming the type 3 binary compounds are different from the first two because it only contains nonmetals. The compound that contains two nonmetal elements are called the binary covalent compounds. Now, let's proceed in the steps upon naming the type 3 binary covalent compounds. The first step is that the first element will retain its element name while the second element will be written in its IDE form. Both elements will get a prefix that will indicate the number of each element in a compound. Note that there is an exemption in the first element. If the prefix of the first element is just a mono, then mono will be disregarded. Now, let's have an example. Here are the prefixes to be used upon naming. For example, the given formula is PF6. So P in periodic table is phosphorus. Since P has only one element, therefore, mono will be disregarded and it will be written as phosphorus. Now, let's proceed in the second element. F is fluorine in the periodic table of elements. Let's get the root of fluorine, which is fluor, then add IDE, so it will be fluoride. The next step is that we will be using the prefix hexa since there is 6 fluorine in the formula. So the name of this PF6 will be phosphorus hexafluoride. And that's how we name the type 3 binary compound. And now, let's have Frances Nicole Alejandro to teach us upon naming the polyatomic ions or the ternary ionic compounds.
Time we will be talking about on how to name a polyatomic ion. Polyatomic ions are ions that consist of more than one atom covalently bonded with one another. In naming polyatomic ions using the formula, we have to write down the full element name of the cation. In this case, Na is the cation and it is sodium. The next is to name the anion, which is the sulfur and the oxygen here. In naming the anion, we have to refer to this table. For us to refer in the table, we have to know the charges of the anion particles. So we may refer to the periodic table for this, and we have the oxygen as an ion with a -2 charge. So we'll write the anion like this, -2. After we found the charge and the number of atoms in the anion, we'll have to look for it at the table. So we have SO3 with a -2 charge and it is named as sulfite. So it means that this sulfur and oxygen is named as sulfite. Lastly, we have to combine the names of these two, and we will get sodium sulfite. This means that Na2SO3 is named as sodium sulfite. Now, if we were given the name and the goal is to write its formula, we have to write First, its symbol. Na is for sodium and sulfite. We will be using the table again, so we will know the formula of the sulfite. So we have to look for the sulfite and write down its formula. So we see that sulfite has the formula of SO3 with a -2 charge. So in order for us to know the number of atoms for the element, we have to write it like this. Na with a +1 charge and sulfite with a -2 charge. What we'll have to do here is to balance out the charges, which is the positive and the negative charge of the elements. Since sulfite has a -2 charge, we need the cation to have 2 positive charges. But since sodium has only 1 positive charge, we will need 2 of them. So we can have +2 charges and balance it out with the sulfite. So if we need 2 of them, we have to write down the number of atoms we will need for the sodium, as well as the formula of the sulfite. And that's how we name polyatomic ions.
And last but not the least are acids. So now, let's proceed with acids. But first, we get to know what are acids. Acids are compounds in which one or more H+ ions are bonded to negative ions. Here are some lists of the negative ions. Now, these are the rules upon naming acids. Naming acids will be based upon the name of the negative ions. If the negative ion ends with IDE, we will be adding hydro at first plus the root word of the negative ion and add -ic at the end. While if the negative ion ends with ATE, we'll be replacing ATE to -ic. Then lastly, if the negative ion ends with ITE, we will be replacing ITE to -us. Now, let's have an example. For example, we have HCl. So, let's proceed in the list of the negative ions. HCl is chloride. So, here's the chloride. So, chloride ends with IDE, so we will be using hydro root plus -ic. So first, we get the root of chloride in which it is chlor. So write the hydro plus the root word which is chlor and -ic at the end. So HCl is named as hydrochloric acid. And that's how we name acids. So that's all for our today's lesson. I hope you enjoy and learned something. Goodbye and see you on our next video.